right? So good transition, because we're going to talk about data sets. Let's get to the point here. Let's start. So the way I'm going to section this off is 30 minutes. Let's talk about what a data set is and the ways to manipulate that data set going forward. And then the last 30 minutes, and maybe everybody's experiences can tell me what they've experienced. Or actually, I'm going to kind of figure out what their experience is right now. How many of you have worked with SQL Server 2012? Okay. 2014? And then how many are in 2016 right now? Good. So this guy over here is going to teach the class, because I have not yet to work in 2016. I worked in 2014 last year, and so I'm learning, and hopefully today we can talk about those features at the second half about 2016 and what you need to do kind of to get ready or move that direction for an efficient data set, right? It's all about efficiency. Let's get that report in under 5 seconds. So I have a couple examples that are actually straightforward for that. Hopefully I can run those correctly. I'm not really demo heavy, hopefully. So let's move on. Sometimes I just like to blather, so Dan will just throw something at me. But what is a data set? What is it used for? And what are your choices? This is pretty straightforward. Straight up query, so an inline SQL statement. You get a result set. You got it in the grid, or you got it to flat file, or you got it out to report. It's just select statement. Select statement, you can do many things with it. You can make it convoluted and complex. You can do derived tables. You can do subquery. You can do a lot of things with just inline SQL. What do you mean by inside SQL? It's just the select statement, right? Right, so yes, that's the first way. So, but what happens there is you can't modify it after you select, right? There's nothing you can do with it. You can select it into a temp table. You can insert it into a regular table. You can insert it into a table variable, but you can't do anything with it. You can't modify it. So that's your first. And so I've worked a little bit in the table variable realm. How many people have used table variables? Wow, a lot more. So this is so I asked that in my user group back in February, March, and nobody was using table variables. I had a tough time, like in February, March. I was trying to join 2 table variables together and on large data sets, and it wasn't happening, right? Right? Do you have that problem? See, silly person. Yes. Why? Because table variable smaller sets, right? Very small sets. Right. Good. I don't have anything free to give away today, but yes. Right. So we'll get into that, and I want to see how you feel about at the end here about the new optimized, the memory optimized table variables. So have you been using those? Okay, so that's what we're going to talk about, and I'm not an expert on this. You guys got to know that this is you guys learning and taking in and saying, okay, I can grab this, and there's examples for everything in 2016. It's amazing. You can just go through and try to figure out things on your own. So there are resident experts on this stuff. I'm just giving you guys an overview of what I've seen. So CT, has anybody been working with CTs? Do you guys know them? Does everybody know what a CT is? Common table expression. So common table expression is, you know what a view is? Have you ever heard of a view? It's essentially a view. But then you get to take that view and use it multiple times again, right? That's kind of the idea. Anybody else kind of have another explanation of what a CTE is?
It's the best way to eliminate duplicate records.
You can use it recursively. Yeah. You can call itself. That I'm not going to get into that. That's way beyond the scope, right? You can get in trouble. So you can set recursion for like twice or 3 times. So look up CT, what it is, get a feel for it. We're going to go through an example. Not yet. We're not going through the example yet. But I'm getting my CTE kick. I swear, everything I think of is in CTE. Is that bad? I sleep in CTE. It's not, and when I go through my example, I'm not talking about efficiency and making things run fast. I want to get something now. I want to get a result set now. So there's going to be arguments because it's not your exact format, but you use it to manipulate the data the way you want it to, right? So we'll go through that, and hopefully I can explain it of what I think it is. But last but not least, temporary tables, our good old buddy TempDB. Temporary tables are tables that reside in TempDB, right? So tables, you create regular tables that are persistent to a temp tables. You can work within the scope depending on if it's local or global. So a global is pound. That's a global temporary table. That could be used within a new query or new session, I think, right? What's technically a new batch, new session?
New scope.
Yes. New scope?
It can be used anywhere on the server.
So
it's global, right?
So it can be used at any time. That's global. Your DBAs, if you're DBAing, you're probably rolling your eyes. I mean, I don't know. You know, I mean, have a lot of people use global tables for production environment use? Yeah. You can actually use global temporary tables within SSIS to pass data between your data flows.
Like,
Yes.
It's kind of like two-line packaging.
Yeah, so you have to have a dedicated source for that, right? So hopefully I don't get too depth into it. I want this to be an intermediate, but those are the uses. So I mean, local, you just write pound and you create a table. You just start into pound Joe table, pound this, and then you can use that temporary table later on, or you can create a temporary table and then add indexes to it. This is another form of working with your data sets, right? So you select into that data set, the global, the table, and then you can modify that when you need it. You can aggregate, you can do a lot of things with it. So these are your options that I see in my realm for data sets and what your choices are. Does anybody have any questions on the different ones? Dan? I don't like table variables, but I think I am starting to like it with the new features of 2014, 2016. So, and we're going to talk about that, I think. Hopefully I get your ideas and what you think. So there's three. So when I talk to my youth group, and I haven't done too many SQL Saturdays, so this presentation may be good or bad, but I try to teach something. I try to, even the guy that has 2016, I try to teach him something new. So question for you guys right now, it has nothing to do with this. How many, so you have, say, a view, and then you have a view inside of a view, inside of a view, inside of a view. How many times can you do that? Does anybody really know? How many times?
The more appropriate question is how many times should you do it? 0. Yeah.
Well, the last time I checked was 32. You can call an object within an object within an object, whether it be a view, a stored procedure. You can go 32 deep. It's good to know, but it's not good to know, right? So you guys learned something today within the first 20 minutes. Congratulations. It's you know, I mean, simple things like that. But I mean, you know, you need to always, when you go to talks, you need to learn something new. And I learned these things in the last year that probably actually are obvious to some people, but not to me, right? So let's go through that. And yes. I did it again. See, I blame this on Ray. So here, I hope everybody can snake this out, and a lot going on, but actually there's not. And maybe I can get help from you in the crowd what these window functions do, And maybe you guys say this is the worst implementation of rank and row number in the world. But our use case was that we're creating a fact table. We're creating 2 fact tables out of 1 fact. We need a fact table that has historical records, and then we need a fact table that we need the latest and greatest current record of that fact table. So we have 2 separate facts. So we brought in all the data into staging, and we're doing a select, and we wanted to know, out of this first example, out of the natural key. So does everybody kind of know what a natural key is, right? So it's kind of a combination of columns that make out a unique record. So we wanted to take that and find the greatest out of the natural key, because we had experience. What?
Highest ID number?
Not just the highest ID, but by transaction date time. So on our source system, if you guys, has everybody dealt source system that you pull it in? Well, our source system had transactions, so the wazoo, right? So you have hundreds, millions, whatever. And we're doing a daily pull, incremental load, and everything's done by transaction date time. So we pulled in the history date, the create date, we called it a transaction date. So if you look over here, so this is the 1757, right? That's the greatest, the last transaction that went through for that unique record, right? And our unique record, we took, let's see if I can explain this correctly, but we said, okay, the rank, and that's going to specify what's your unique record without the history, and then we added the history date after that, and for the row number, and that will give you the row number will give you the 1, 2, 3 within that unique record, that natural key. Does everybody kind of have any questions on that?
What kind of sort was this a client sort of system?
Yeah. This is
the first thing I was wondering is why do they log L's in their ID columns? Is that easy?
Yeah. So we'll get past that. So yeah.
No, you have to deal with what you have to deal with.
Yeah, I don't remember which exact fact this is, but yeah. So we had -2. So Knowles specifies -2s in the dimension policy. Oh my gosh. So yeah, we could get into semantics on that. I mean, if you really wanted to, but so you know which one's the latest, right? And we wanted that in the current fact table instead of, we could do a group by, right? Would you do a group by? So the question was, how would you guys go about getting the latest record if you had to do that within the fact, right? Do you have any good solutions? I don't know. I mean, this guy, he'd been working there for a while, and he gave this to me. This is something that I learned. I'm like, whoa, okay, this is awesome. So now we have this in our.
The only difference I would do in this, if I were to do it like this, and probably I would, is I would use a partition by and get rid of one of the window functions, get rid of the ranking function, and just use row number with partition and order.
That's what somebody said at the last one. I didn't modify it. I didn't have enough time, but so this is what they're using there, and that's exactly. Could you say that again to let everybody know? I mean,
It basically what you're doing is you're taking the rank and you're partitioning your data by order ID.
Yep.
And then you're doing row number. You're kind of ranking within the rank.
So you're partitioning.
So your ranks are 1, 1, 2, 3. So you're sorting your ranks within the rank. And partitioning, you can partition the row number or the rank for that matter, where you can get it to do, get it to do that number in one window expression rather than two window expressions.
Yep, that could be another way of doing it. And at the end, when they want the current, what they do is my rank equals my row number.
Right.
So when you do it your way, you would just say row number rank 1.
Yeah.
Rank 1.
Yeah.
And all the top ones would be rank 1. Cool. See, that's working with Datasets. Has anybody seen this before, or I mean, is this kind of new? I mean, would you ever use it? I don't know, but I thought it was cool, and they did it and it worked, right? So there's a lot going on there. I'm sorry. But you got questions? Yeah.
I'm just trying to read. There's a lot going on.
There's a lot going on. I mean, we're doing is nulls, and then really just the row number of the rank.
Values.
What?
You said a transaction type and transaction. Those are equal signs. So you're setting values as well.
So.
You don't have lines. Yeah.
Oh, he's just renaming them, right? This is transaction type. So that's just like an as, right?
Is it? Okay. I thought you were setting it as a value.
Yeah. So I mean, that would just be the transaction.
Those aren't variables, so I guess you're not.
Yeah. Yep. Okay, now if I didn't confuse enough there, so we'll see how this one goes. Okay, so we had a history table of work items. So people would do work, a work item would come into the work item history table, and it'd have an ID of one, and then you start working on it, and you do all these modifications. So let's go 3109. We kept on working on it, and they have different statuses that say what's going on. And it came down, they're like, oh, we forgot to add a status, but we created a different table. I don't know, it's client data. So they don't have status for pending records, and they have a different table. And so the problem is, we want to know when that pending happened, and we want to take the last time it was worked and it was assigned, the last time it was assigned, and then we want to know when it was released and do a date diff for minutes, because we want to see how long it took them to assign it and then release it within that last time. Okay, and in order for me to take the data and create that on one record, right? I want that one on one record. I want to know, see if I can explain that even better. I want one record that says, okay, this work item was assigned and released in 10 minutes, and just have that on that one record line for that work item. So that's what we're going to do here. Does everybody kind of understand? It's anybody have any questions? Let's just say that. I'll move on to the actual.
So the pending work item it's a table where the work is to be done. It's not completed.
So what happened? It's insurance. So what happens is they got a work item, and they're going to work on the documentation and say, okay, so this is insurance. Well, we need to send that out and get more information. So that's part of the pending stuff. Like, we need more information. So once it's pended and completed, and
so it's a workload.
Yes.
Issue. Okay.
Yeah. So what I was tasked to get this done in like 30 minutes or an hour. I didn't have long, and I knew that it wasn't going to be the most efficient, like we're talking about. So I've been using CTE. And so what do I need to do is show you my solution, hopefully. There's a lot going on here. I know I kind of should have supplies, but I had to cast these because I had to create my own record set because I don't work with that client anymore. So I had to create it, and then I had to cast things. But essentially, this is the same select statement you just saw, and I just did it for those two work item IDs. So first of all, when I want to bring two data sets in together, here we go. When I want to bring two separate tables like that, and you don't know, they don't match up, you can't join on them. Usually you join and you get the two records, and you can do a data. That history record was created, it would give it the same date time stamp as the one in the pending, so you don't know when the pending happened, right? You don't have that relationship. The relationship broke down, right? So you can't say work item ID 3109 and say this happened on history create date today at 2. You can't join that against the pending because the pending happened later, right? Maybe 2 seconds later, maybe 3 seconds. So you can't join. So what I did was I actually union. Does everybody know what a union is? So I unioned them together, and this is the first part of it. So you union them together, and you see now we don't exactly know. Well, we do kind of know when these happened, because based on, don't look at the create and the last step, just look at the history date. You know when it happened because you can put it in between a different record. So to explain that more, what I will do is I wanted to give each of these a unique identifier, so I just use row number, and I did it by work item ID and the history create date. So that'll give me my result set with a unique identifier. And if I do this, so now I have my new data set, right? And it has a history ID that's unique to each record based on a history create date. And now, there you go. Pending followed in between where we needed it to be. There's a lot going on here, and I'm gonna keep saying sorry, but if you look here, it looks like it was assigned at 135 and then appended at 1525 and then released or completed at, I think that's it. Well, I should have put the names on there, but I think status 4 is complete. So, okay. But yeah, so this will give our first kind of say, okay, where does that record need to lie within our set, right? Because I used the order by work item ID, and this gave us a unique identifier. Does everybody kind of see what I'm doing here? So now with the CTE, now that I have that, a CTE is just, let's create a view of this and then be able to use it later on and just keep building from that. But, and actually some CTEs you can do a lot of records, but I wouldn't suggest them on a production environment. But, so our first select statement within, after our CTE creation. So we have this, and this is the CTE. This is the view that I'm going to call multiple times, and we're gonna relate back to that, and I'll show you. So first of all, the CTE is called WF history, right? And I called it an alias of A. So every time I use A dot, I'm using that table, right? So I use lag, and now what does lag do? Does everybody kind of know what lag is? So lag is a windowing function that gets the previous record. So you have
not necessarily just the first movements, right? Go back.
Yes. So I've set it to 1. You can set it to as many as you want, right? So lag is a function that says, okay, based on what column you want, I think you do multiple. I don't know, but I said work history ID. I want to get the previous work history ID because now we have it in order, right? Now we know that this was our previous record, right? So 4 and 3, this is our key, right? So base that off of the work history ID. We can order it by, and that would give us a previous record from this result set. So let's go ahead and do that. Okay. So now if we look at our result set, we have a previous history ID, and that's actually at the end. Sorry about that. So there are probably issues that I didn't cover, like what happens if you're at 0 and you don't have a previous. So we won't touch on that. But for this example, you would look at this and say, okay, so for our appended record, our previous is
record before 4 is 3.
yes, right? There you go. So now you know what your previous record was based on your history, transaction, date time from both tables, right? And now you can grab the information from that, and that's where your CTE comes in handy. So we'll go ahead and do that. So I'll go ahead and go back into our implementation. Oh, I guess I don't need to. I already have it. So now, this is the crazy thing. You can get complicated and convoluted, and you can just keep going and making changes onto a CTE. But here's, if you can read this, what we do is then go back to the original CTE, and we do a join against that new previous work history ID, which is 3, and then we grab everything from 3 because we join against that old history. Does everybody kind of understand that?
Yeah, you're trying to get that correct.
Yes.
You're trying to get 3 and 4 on the same row.
Yes. Everybody? Yeah. So, nope. Yes, there you go. So that was the kind of thing that I had to come up with, like 45 minutes or an hour. And so they wanted that, and then I think they, of course, the client's like, oh, we don't need these tables in this table, and we're like, okay. So, but I thought it was cool because I use CTE, and then after that, so I joined those, and then I found what was the previous assignment date, and I did kind of layered it. You can keep layering, and that's what I did with this. You know, just keep calling the CTE or calling the record within the record. You can't do that in inline SQL, can you? Can you do this in inline SQL? No, I mean, do what I'm doing here now. So and can you do that within a table variable? I guess you could, if you really wanted to. You'd have to have multiple table variables. You have to have multiple temp tables. You do updates, blah blah blah. This is quick win. So this is exciting because then you get, you know. So if I run it all, that gets me my pending period of, you know, let's not check the actual, you know, results because I don't know if it's right, but so this happened 110 minutes from your assignment to your release, and this happened 98. So moving on, since I'm taking up a lot of time on this.
That's the metric that you're trying to measure.
Yes. Yeah, how long it was pended, and then let's join against some other tables and get information. But so that was my first. That was my big example. Does everybody kind of understand what I was doing there? And that's why I think of CTEs. I'm just like, you do all this different stuff, and we were doing result sets from the fact table, and we were doing CTE stuff. And sometimes it was performance, sometimes it wasn't. But so I'm not telling you guys that you should go out and use CTE on a production environment and say, okay, this is going to work really fast, because it may not. It all depends, as the saying goes, right? So
the more iterations to access of a single CTE, the more costly it gets. And
yes.
Maybe geometric, I'm not sure. Yes. Because each time a CTE runs, it goes back to the original.
Yes, exactly. So know your set. Know what you need. If things are running slow, extract this, simplify it. Ray did a presentation on client and information. Keep it simple, stupid. KISS methodology. Keep it simple. That's what I try to do within my data sets, except for here, because this was I needed this in 30 minutes. I needed this now instead of later. So you can extract this and do temp tables, right? And make it really fast, perform it in the stored proc or whatever. So that's that situation, and that was kind of my bigger one. Now, I'm sure all the DBAs out there are probably like, this is the simplest thing, but you know what? I didn't even know really existed until you brought it up. Can everybody see that? Is that bright enough?
It's a little small.
I wonder. I don't think. Yeah. And this is actually a simplistic thing. That's what I said. You know, you can remove duplicates quickly. I don't know if you want to do this, but so you have a table, you have a unique non-clustered index, and you have a problem because you're inserting duplicates. Say if you have a fact table and you just a lot of times you can just have duplicates if it allows for it, right? But what if you don't want them there? Then, because right now it'll fail. So this is the example. It inserts 2 records, John Doe and Joe Doe, and then it tries to insert a third one that's the same as John Doe, and it fails on duplication. And this was great because you used the ignore duplicate key. Has anybody used that? Has anybody heard of that? Has everybody heard? Who's heard of that? It's got 3, 4. So there's actually, you can say ignore duplicate key. And what does that mean? Well, it ignores it. So it doesn't, so when you insert, it doesn't throw an error. It just throws so if we go down here, you have the 2 insert and then the third. And what you'll get is duplicate key ignored. So you'll only have a result set of 2. So that's a quick win if you're trying to remove duplicates, right? You only get 2 records.
So the third insert just fails.
It doesn't fail. It just ignored it.
Well, okay, yeah.
It tried.
It didn't fail the SQL.
Yes.
It just didn't insert.
It just didn't.
Okay.
Yeah.
Yes.
You don't get a,
That's not the behavior I thought it did. Okay.
I wonder if we get logged on that. Does that get logged? It's weird. I would have that set. It would be logged. Okay.
because you got a message.
Yes. So that was another thing. I mean, I was like, that's cool. I may have heard that one, but here's my thing. Okay, now let's talk about the nuts and bolts. And of course, this is more talking than me teaching. I'm going to show you a demo that comes with 2016 CTP download. I don't know, has anybody in here downloaded the examples for 2016? Good. Then you should. You should understand what the new features are and see how cool it is, and what, you know, it could be possible that you could get it in your environment. But let's talk. Does everybody know what operational analytics is? That was the big thing with 2016. Does anybody not know what operational analytics is?
Yes, but I don't know what it is specifically.
So does anybody have a real-time database?
All databases are real-time.
A real-time solution for getting reports.
A reporting database. Real-time, no. Real-time, yes.
That's the big discussion. Like,
How real time?
how real is real-time?
Yeah.
So
For us, it's 2 hours.
What could I give anything really because it's not time? All you need to do is to copy a very large file and watch the time for something minutes.
So SQL Server 2016, and this is their solution to it is, and it's been building up, right? You have your column store indexes, and then you have your in-memory capabilities, right? And so it's the combination of those, mostly column store, that can give you that ability to put it on your OLTP system. I'm not saying go out and do it. It's for certain instances, right? But have your OLTP system be your reporting system, and be able to do large aggregations on really large data sets on your production source system, right? You can do on the fly. So combined with doing R stuff, if you really want to do fraud detection, it might not be as real, but this is like, say, you don't need a data warehouse. You can just do your summations, aggregations right there on your OLTP system. That's what they mean by operational analytics. Being able to use the new features. And so column store, does anybody not know what clustered column store is, or non-clustered column store? Everybody knows what column store is. So 2012, you had non-clustered, not updatable. 2014, you had non-clustered and clustered. And clustered was updatable. Non-clustered was not, right? Still. So that's That's the problem, because you had non-clustered that was not updatable, and so now it is, right? You can update your non-clustered index. Clustered column store is the whole table. You don't specify what your columns are. So now you can specify your tables, and you can create a clustered column store and a non-clustered column store on the same table.
You need to column store index.
No,
I think if you have
But-
one, doesn't that cover all the columns?
but now, one thing they did allow now, it's clustered column store and a non-clustered index. You can add
Yes,
non-clustered index.
yes.
So you have the best of both. But yeah, you would never want to put a clustered column store.
Two
in.
column stores on the
Yeah,
system.
you'd never want to do that, really, right? Because it'd already be at columnar fashion.
Yeah.
So when you say columnar, everything's in column form, right? It's compressed that way, and it's really easy to aggregate over 1 million records. So if you download, go to the examples, which I did here, and we can start walking through that. That's what I want to walk through and see who's experienced it or who's not. But giving the ability to do operational analytics, being able to do your data warehousing summations on your OLTP system. It seems like a far-fetched idea, but that's what they're trying to do here, and they've given you the tools to do that. If we go ahead and look, I'm going to go ahead and show you that download that I have in my slide. Has a link to it, and you can download. This is the 2016 CTP3 samples that I downloaded. Here's all the samples that you can do just with your 2016 Developer Edition. And you can go through here. Look at you got Polybase, Query Store, and they have all examples. So we're going to go in here and we're going to look at the clustered column store samples. I'm just going to quickly go through the example and kind of clarify what column store is, because a lot of people just don't understand when you need it. And I think maybe 7 months ago I didn't really either, because I was doing detailed queries on a. I was like, this isn't more efficient. It's not used that way, right? When you open up that SQL query, this is what it says right here. This sample targets data warehouse workload. We recommend using clustered column store index for large tables, 1 million plus rows, and traditional row stores for tables of size of greater than 1 million rows. So that's when you'd want to use it, right? And traditional row store for less than 1 million rows, right? So because if you're going to aggregate large amounts of data. I mean, that's the way I understand. I mean, you could do a whole talk on column store indexes, and I'm not going to get into that. This is the start of the operational analytics. We started with 2012, 2014, and you can use the new features with the 2016 updatable clustered column store index, add it with a non-clustered index, and you can also have keys, foreign key constraints on it too as well. So there's a lot of new features involved. So I'm going to go ahead and go to step 8. So there's a lot of different things you can do here. They got page compression. You can run through how things run. Let's see what database I'm on here. Connect. Okay. So I'll go to step 8. That's what I want to kind of show you. And then we're going to do in-memory stuff. Oh, yeah. Thank you, Dan. Okay, so going back to what a cluster column store index is, use columnar, but then with the regular non-cluster index, it's V-tree, right? It sorts through that way, right? Does everybody kind of understand that and understand what the difference is between a regular non-cluster index and column store index? So if you add those together, what you have is the ability to do detailed selects statements, your detailed query. So in your where clause, you can do detail and still get performance because you have both the non-clustered index and the clustered column store. So you add those together. This gives you an operational analytics table. Does anybody kind of not agree with that, or I don't know? Understand what I'm kind of throwing at you? So this example, I'm going to make sure this is on this. You need to restore the AdventureWorks 2016 CTP3. I restored that because after this we're gonna create millions of records on here. So actually I needed to be at the data warehouse level. Sorry. So I'm gonna go ahead and set that to 130, which is the 2016. Make sure that's there. I'm gonna clear all the buffers because when we want to do this, we want to see how fast things are, and just with removing those. So this first one is going to be, we already have a clustered column store index on this table. That's why it's called _CCI. And then we're going to do joining against dim reseller, and we're going to do a reseller name equals wheels incorporated because it's detailed. This is detailed. This isn't, when you do this query right now as is, you're going to have not the cost benefit of a B tree, and you need that. And so that's what 2016 allows, that you have that non-clustered index on reseller name. And so we'll go ahead and run that. So obviously we're working with not that large of a data set, but if you guys can remember, actually, maybe for example, maybe I just copy, so when I ran it, it ran in 54, and CPU time was 16 and 102. Maybe I'll just copy that, and so we can have a side-by-side comparison. Because now, if we go ahead and create a non-clustered index on that table, of course, I downloaded and installed Visual Studio, but it must have created it. So I've been getting errors with the new SSMS and installing Visual Studio Azure tools. I don't know why, but it happens. So it must have created it within that statement, even though it had that error. But so let's go ahead. And so now that it's created on that table, and we have a non-clustered index, which is not column store, and then we have a clustered column store index on that table. I mean, if we go to it, maybe I'll verify that. So there you go. So you have that, and you couldn't do that before, and you couldn't create primary keys. So that's it's definitely improving on what they had in 2014. So now let's see what happens when we drop the buffers on it and see if that helped us out in the long run. Hopefully I didn't erase my. So instead of, it did make it more CPU, but elapsed time was 23. Looks like, so as far as, let's see if we can paste this. So we have SQL Server processing compile time. It only took 23 seconds, but it did up the CPU time. And it did, for elapsed time, it took 218 seconds. So, but if you go back, so it did do a little more on the parse and compile time, but maybe if we try it again and see if it'll help. But See, demos are not meant to be always successful, right? You always fail at something. So if we keep running this, maybe over an average, maybe it'll see like so we have nothing there. But I mean, maybe that's cache now. So, but the idea here is that you can create the functionality of a B tree on these certain columns like you would on a regular table. You couldn't do that before if you had clustered column store. So if you have a fact that you need a non-clustered index on, you can do it now. So, does anybody have any questions on that? So I got, what time is it right now? About 10 more minutes? Okay. So let's quickly go over in memory. That it's been in there since 2014. So you can combine in memory with the clustered column store, and we'll go straight to the example, which takes 8 minutes, so we probably won't go all the way through, but so what the example gives you, it gives you the database, CTP, not the data warehouse, but the database, and in there it has an OLTP sample that you back up, and it actually has pretty cool instructions in the README. So it uses RML utilities to do load testing, and hopefully this will work. But what I mean by load testing, it does, I'll get these wrong, but 100 threads, and each thread will do it 500 times, so it creates about 1 million records. And what it does is call a stored procedure within this SQL query. And inside that, it calls it 20 more times. So that's how you get 1 million records. And we'll do the memory optimized because that's quicker first, and then I can start on the so it should take, well, it had been taking 1:24, so hopefully it didn't take too long. But if you go ahead and look at this example from the nuts and bolts, and hopefully I can get this quickly. What it does is it uses a table variable and makes it in memory. So in memory meaning using memory. But I don't know how to give you any better explanation than that. But what it does is it creates a type. And since I only have 10 minutes, I can't really go through it all. But here's the passing of the table variable. So this is where I'm going to start working more on table variables. I think I'm liking it because I see its use now. And it runs a lot faster than disk space, and you'll see that in the demo. But so when you create a type of in-memory table, you have to select bucket count. And in this example, I'm going to save this and have it on there because they didn't really go how to get the bucket count. But you need to specify bucket counts for hash indexing, and I'm not going to go through hashes. So I'm going through things fast right now, but you need to do more studying up on what a hash table is, hash index is, but this makes it so it goes really fast. And so it creates a type of that table, and then you use the hash index, non-clustered index, and then you have memory optimized on. So this is in the example that's given, and it's passed through the stored procedure. And the stored procedure has to use atomic because to use in memory, you need to have atomic instead of begin tran, because atomic automatically rolls back. It's a one and done thing. Like if it fails, it roll back automatically. So that's why that's there. But yeah, I mean, so this is what we're doing for 100 threads, called it 500 times, and then 20 times in here. Let's see. The perils of demoing live, right? So it's called here, it's called within that statement. I don't know if I have that open. I should. Must not, but it's called 20 times. Let's see. Get rid of that. That. But this is called 20 times in that SQL statement. that's all it does. It loops through 20 times. So 100 threads times 500 times 20, I think, is 1 million. So we should have 1 million records in. I should have done the select statement. It's inserting now. Should be 1,034,000 or something after it's done. So there are certain things that you need to that are you need to read the white pages and say, okay, so what can I create and use for table variables, and what I can do and what I can't. Let's see. So that's passed in there, and then so this is the in-memory table, and so this is the one that's passed through, and then it seems like this is much more performant than a regular table variable, in that we're doing summations on this, and as it's all in memory, so it really is a lot faster than my experience with regular table variables. So when I ran this last week, for example, the in-memory took only 1:29, and then the disk space version of this, so essentially disk space is the same thing except it doesn't use in-memory table variables. It took 8 minutes. So yeah, a little bit of difference, and we're just inserting, right? 1 million records.
So I'm going to ask you a technical question.
I may or may not know.
Yeah. The in-memory that you're doing, is that within the SQL Server memory space? Do you need to be concerned about?
Yes, I would say.
On the server, again, how large is that?
Yeah, it definitely is. Yeah, it's with the scope of
the same SQL Server memory allocation. So if your SQL Server is short on memory, you don't want to.
Yeah. I'm not at that DBAS level, so I think you would definitely need to talk to your so I'm looking from this as a developer standpoint, and I'm going to start using this type of technology. You need to talk to your DBA, because I think the DBA needs to know all this, right? But I go on different client, and they don't have a DBA, or they don't care.
What's that?
Temp DB, let it just explode. That's it's kind of funny that way, but DBA, it would. If our marketing could grasp, yeah, if our marketing could figure that out and do like a consulting DBA, but yeah. So this is taking forever. What? Ah, there we go. I know. Do you know Ginger Grant? Yeah. So she's our SQL Server MVP. So she just became a SQL Server MVP last year. This was last year, so exciting, but. So, we can look at the actual in-memory, the disk space one. So the disk space insert, well, I'd have to go in here. But, so in closing, since, that's not working. So, like I always say, and I said this last year, that you fail to succeed. So my demo kind of failed because I don't know why my SQL Server is running really slow right now. But that happens. Like I failed before on an SSAS Power BI implementation. I had my SSAS instance and I connected my Power BI. And then when I got there, I was on their internet and it would not let me get on my network. So because you just gotta go with it. But it's really exciting. So in ending, you have operational analytics. Look into it, understand what's going on there, because I think it's the future. I think you'll still have your data warehouse. You still need your data warehouse because you're going to need data to be cleansed, or you have your master data management solutions that pull in data. But to get some sort of operational real-time feel, that this is what they're throwing at you, and I think it's cool. Now, I hope to get on a project this next year that will implement this, in a real live scenario. And I'll be creating a presentation on that. But what I've seen, I think it's promising. I have my references at the end. And then, does anybody have any questions or comments?
Thanks.
Thank you. Thank you for coming. And thank you for those people online. Hopefully I was loud enough. I'll have to find that.